Acoustic emission, or AE for short, is a fast and effective method of determining the health of rotating elements. The MHC Memo Pro utilizes AE to listen for friction and impacts caused by poor lubrication or bearing damage. Sound is generated by bearings, and this propagates through the structure of the machine. Using a sensor to pick up the signal, you can detect this noise, and using signal processing, determine the condition of the bearing. Kittiwake Holroyd's acoustic emission technology has been used on all types of rotating equipment for over 20 years. Why we work at the frequency we do. The audible spectrum is an extremely crowded place, typically stretching from 20 Hz to beyond 20 kHz. By using frequencies above this range, at around 100 kHz, it is possible to ignore the audible sound and all of the attendant background noises and focus on the specific noise caused by damage within the rotating element. Another advantage of measuring at this high frequency is that sounds only travel short distances at these frequencies, thus allowing us to be specific as to the location of the defect. Much above the 100 kHz measurement frequency, the attenuation is severe enough to limit what is detectable. Acoustic emission versus vibration. Vibration is insensitive to the early signs of a problem unless complex signal analysis is carried out. The acoustic emission method does not require this analysis. However, should you wish to, it is possible to perform complex signal analysis using the Memo Pro and software. Because this analysis is not required to interpret results, the speed and ease of measurement is dramatically reduced compared to vibration analysis. Also, AE uses a single sensor to detect signals and does not require data collection in 3 planes as required by vibration. This de-skills the condition monitoring application to a level where complex training and understanding of fast Fourier transforms is not required. Interpretation of data. In standard mode, the MHC Memo Pro provides 2 easy-to-interpret parameters, distress and dB level. Distress is a measurement that quantifies the impacts occurring within the rotating element being measured. Even in brand new bearings, impacts will occur. The base level for distress would be the perfect bearing, which would theoretically have a distress figure of 0. In real life, bearings usually start their lives with a distress value of 2 or 3. During the life of the bearing, this value trends upwards. Experience over many years has shown that if a bearing shows a distress value in excess of 10, the bearing should be lubricated and the distress value rechecked. If the value of distress remains above 10, then further investigation and possible replacement of the bearing should be considered. dB level quantifies the frictional activity taking place and cannot be easily estimated. The level of dB is dependent on the speed of the bearing, but only increases as wear increases for the same rotational speed. Usually, the user would take a first reading and trend from that value or compare to a similar machine of similar age doing the same job. By trending this, the user can monitor the speed of degradation. A rapid increase in dB level is normally the final warning prior to bearing failure. Stages of failure. Stage 1. Good. dB low for this machine and speed. Distress less than 10. Less than 5 is very good. Stage 2. First signs of possible problem. dB still low for this machine and speed. Distress fluctuates around 10. Stage 3. Problem becomes established. dB levels may slightly increase. Distress consistent with 10 or above. Stage 4. Continuing degradation. dB levels increase. Distress may fluctuate, even drop below 10. Stage 5. Approach to final failure. dB levels readings increase at an accelerating rate. Distress value most likely to be low. What can acoustic emissions be used on? Kittiwake Holroyd's acoustic emissions instruments can be used on most rotating machinery, including pumps, motors, gearboxes and bearings. The MHC Memo Pro is very versatile in the range of operating equipment speeds that it will work with. It has two modes that can be used. Standard mode works for speeds greater than 35 RPM. Super slow mode works for speeds between a quarter to 60 RPM. How to use the MHC Memo Pro. The MHC Memo Pro has 10 control buttons on its keypad. On, off, volume, backlight, menu, edit, store, hold and 2 scroll buttons. Where to place the sensor? As we are working at such high frequencies, sound does not travel great distances. This works in our favour, as it allows us to be very specific as to where the fault is. It also means that we need to be fairly close to the bearing we are measuring. Orientation is not an issue, as sound waves travel in all planes. However, joints reduce the amount of sound transmitted through a structure. Ideally, select a point on the machine that is as close to the rotating element as possible, but with the fewest junctions within the sound path. The sensor should not be placed on loose covers or guards that are not directly connected with the source of the sound. Once a suitable place of measurement has been located, a galvanized steel pad can be bonded in place. This ensures that the measurements are taken from the same position each time, thus increasing repeatability. These pads also provide a flat, smooth surface to take a measurement on. Extended probes can be used to take measurements in difficult-to-reach locations for both standard and slow mode. How to take a standard mode reading. To take a measurement, turn the MHC Memo Pro on and wait for the displays to 0. This usually takes just a few seconds. Apply a small amount of grease to the measurement point to ensure a good audio coupling. Carefully place the sensor on the measurement point at 45 degrees and, using a rolling action, flatten the sensor onto the test pad or location. Twist the sensor slightly to ensure a good coupling is achieved. Allow the readings on the display to stabilize and then take measurements of distress and dB. These can then be simply interpreted, with distress levels of below 10 indicating a good bearing and above 10 requiring further investigation. How to take a super slow mode reading. Taking a super slow measurement is similar to taking a standard measurement. Turn the Memo Pro on. Choose super slow mode instead of standard mode. Attachment of the sensor is identical for both methods. Super slow mode requires the user to enter the approximate rotation speed in seconds per revolution. Once entered, the MHC Memo Pro acquires measurements from 9 revolutions of the rotating element being tested. A number of parameters are then displayed: peak, intensity, extent, and dB. Peak, intensity, extent, and dB. When a rotating element moves swiftly, there are plenty of frictions and impacts to monitor. However, when the speed of rotation is slow, there is little data to work with. Consequently, along with dB, the distress parameter has been divided into 3 parts: peak, intensity, and extent. Peak quantifies the largest spike of power released from the source of impact. It is always the highest value of energy measured and is most useful as an indicator of a significant singular event. Intensity determines the average amount of activity occurring over the measurement time frame. This parameter is often used to quantify the rate of degradation of a rotating element. Extent is the percentage of the cycle in which activity is present. It is very useful for detecting start and spread of generalized damage. dB level. As in standard mode, dB level measures the frictional activity present. However, at slow rotational speeds, generally the values will be minimal, possibly even 0 in certain circumstances. When trending data in super slow mode, dB level is generally at a level of 4 or below for an undamaged bearing. Interpretation of super slow mode readings. When analysing super slow readings, the following approach is most widely applicable. Machinery in good condition usually has an extent of 5 or less. The presence of a high extent value is usually an indicator of damage. In most circumstances, the extent value alone gives you the information you need to identify the presence of a fault and rank its severity. For readings with a high extent, observe the intensity value, since this shows if the magnitude of the activity is getting worse. Peak comes into its own when a large singular defect occurs, for example a cracked race, at which time peak would markedly increase, even though the extent value may remain 0 or very low. Always take a high peak reading seriously. Also, don't forget to listen to the activity on the headphones. Using the headphones to analyse data. Although not required to understand the condition of a bearing, the use of headphones can offer further information for the user. The supplied ear-defending headphones cut out background noise, and the MHC Memo Pro demodulates the 100 kHz measured signal down to a frequency where it is audible by the human ear. This is useful in determining the nature of a specific fault, for example the inner race fault that you can hear now. Auto-log. The MHC Memo Pro has the ability to store a stream of measurement points in its memory for further analysis. This is called auto-logging. Auto-log files can contain either standard or super slow mode measurements. The memory within the MHC Memo Pro can save over 40 minutes of data. This can consist of one long sequence or multiple smaller sequences. The size of each auto-log file depends on the length of time each sequence was recording for. Auto-log files are downloaded along with all other stored information when Quick Unload is used within the Transfers tab page of the supplied Analysis Pro software. Alternatively, auto-log files can be downloaded independently using the Advanced Transfers facility. Each auto-log sequence has a file name which consists of a field-defined file name, up to 12 alphanumeric characters. They are text files and can be readily opened in spreadsheets where they will appear under the column headings of point, date, time, distress, dB level, peak, intensity, extent and time per revolution. These can be analysed further by the user as required. Routes. When walking round a factory measuring sets of equipment, it is logical to follow the same route and take measurements in the same order each time. The MHC Memo Pro software allows routes to be set up and pre-programmed into the unit for ease of use. This ensures that the same measurements are made in the same order on each tour of the factory. The supplied software makes this process simple to set up and to interpret and trend the measured data. Software. In order to create routes in your MHC Memo Pro, you must first create a database on the PC with all of the measurement points in it. The route can then be downloaded into the MHC Memo Pro. Open the software by double-clicking on the Analysis Pro icon. Once open, click File, New Database and create a name for your database. Confirm this by clicking on Create. A page will appear and it will display Nothing found in current site and area. To add a site, click on the red plus symbol. Enter the chosen site name. Create a named area by clicking on the plus symbol on the right of the Area tab. This is the area in the site you have machines that need measuring. For example, the site could be your factory location and the area could be process line 1. Once created, two new tabs appear at the bottom of the page. These allow the user to add more detail into the database machine and point. Machine is the machine on which the measurements will be taken, and point is the point on that machine where the measurement is made in case of multiple measurement points on a single machine. When creating a point, before entering a name for the machine, you are asked to specify if the measurement type is standard or super slow mode. Manual parameters can also be selected if there are such variables as pressure, temperature, current, or flow. These can also be trended in the software if required. In order to add similar machines without having to re-enter all the information, click the Duplicate tab. You will then be prompted to change the name of the machine, but the software will duplicate all other points. These can be edited in turn if needed. By adding this detail, you have created an organized and detailed database ready for data to be entered. In order to upload these routes into the machine, they must first be saved as a list file. Save the database you have just created and then select Exit Database. This will take you into the Action List page where the information is ordered for the user to view the details. Add the machines sequentially in the order you wish to measure by selecting the machine and clicking the plus tab. Once finished, click on the Action List tab and then save the list. Before uploading the routes to your MHC Memo Pro, it should be switched on and in the normal powered-up state. Make sure the correct COM port has been selected for the device by clicking on the Setting tab at the top of the page and selecting Set COM port. Click on the small computer symbol arrow and select Search COM ports for MHC Memo Pro. Once found, choose OK and you are ready to transfer to routes onto your device. To do this, simply click Load Route and wait for the data to be transmitted. You are now ready to take readings from your machines. Simply follow the route displayed on the MHC Memo Pro screen. When you have finished following the route, plug the MHC Memo Pro back into the PC and make sure that it is in the normal powered-up state. With the software running on the PC, load the correct database. Select the Exit Database tab and load the action list you are using. On the Transfers page, select the Advanced checkbox and choose the Route for Database button. Follow the on-screen instructions and wait for the information to be downloaded into the PC. Once downloaded, all the data is viewable by using the tabs along the bottom edge of the screen. Exceptions. An exception report allows the user to generate a report focusing on the points of concern. Missing points. If the machine isn't running, it is possible to skip points on the MHC Memo Pro. The software reports which points have been missed. Trends. Trends show the rate of degradation, which is by far the most important data to be gleaned by condition monitoring. This allows the user to decide if immediate action is required or during the next routine maintenance cycle. Store photos as a reminder of monitoring location. Photographs can be embedded in the software to allow reports to be generated and to allow users who are unfamiliar with the routes to know where to take the reading. Search function. The strength of a database lies in its ability to extract multiple levels of data from a record. The search function enables an operator to search by most parameters and contrast and compare similar equipment. Setting alarm levels. Distress is set by default at the recommended alarm level of 10. This can be amended by the user. dB level is set at, by default, to 99, because the typical value for a given machine will vary depending on the machine and its speed of operation. Best practice detects that after the first set of readings are made, the dB level alarm is reset to approximately 10% above the initial value to ensure any significant increase is flagged. Reports. Multiple report formats are available, including the option to print out a page showing the rate of degradation of an individual rotating element. This gives distress and dB, or in super slow mode, peak, intensity, extent and dB, along with their alarm levels in both digital and graphical representations. AE Lab. AE Lab was created in order to view the full dynamic envelope of an acoustic emissions signal. This analysis is not essential with the Kittiwake Holroyd device, but can yield further information as to the nature of the defect. The minimum speed of rotation for spectral capture is 120 RPM. This mode can be accessed on the MHC Memo Pro by selecting No to Routes and selecting Standard Mode Readings. Capture Spectrum can then be selected, allowing the creation of up to 15 spectrum files. Take a reading, save it, and then move to the next measurement point or download the data to the PC. Downloading the data follows the same procedure as Autolog. First, open the Analysis Pro software and then the database previously created for the data point. Follow the same steps as with Autolog to the Transfers page. But after clicking the Advanced checkbox, select the Spectrum button. When you select to upload a Spectrum file, it is automatically saved in the database in the Capture Spectrum folder. In order to view a Spectrum file, open the AE Lab software. Once open, AE Lab allows you to view the whole waveform to find the peak signal amplitude. From its frequency and harmonics, the damage within the rotating element can be determined. Properties of the rotating element must be entered into the database by clicking on the Hertz symbol. This information is then processed and the defect frequency found, allowing the user to determine the fault within the rotating element. By clicking the Find Peak button and then selecting the Harmonic Steps box, the defect frequency is highlighted. This can then be compared with the data in the lookup table and the defect confirmed. This video has shown you how to use the MHC Memo Pro and the ease and simplicity with which you can measure and monitor your critical rotating assets. Both slow speed using the super slow mode and normal measurements using the standard mode have been described. The supplied software allows you to create routes and trend and analyze measurements from them. The further advantages of Autolog and spectral capture have also been covered. If you have any further questions, please contact your local Kittiwake Holroyd representative.